Hello, this is Industrial Control Circuit Troubleshooting 1, 4th module. Now we are doing Genius Skill Test number 6. The work order that we received stated that the water overflow from the tank and unable to pump out to the next stage. So what is the problem? Let's dive in. I first look from the external device. On the external device and the circuit, I noticed that the EMO switch was pressed, so I have to release the EMO. So there's a lighting, power lighting turning on. Okay, and I also observed that there's a water inside the side glass, and the water actually at the maximum level. So I try to drain the water and we run the process. Because I don't see any other anomaly from the circuit or the external device. And after finish draining out the water, I will run the process and observe for any anomaly. Okay, run the process. Something is wrong here. First thing I observe here is the alarm lighting did not turn on and the intake 2 lighting should be off, but it still turned on. Okay, so by looking at the circuit, we know that when water level reach 90% and above, it will trigger the float switch 4 to close mechanically, and the AC current can flow through this path to energize R9 relay coil and alarm lighting. However, the alarm lighting do not turn on. So most probably the alarm lighting having internally open circuit, or the wiring having open circuit or loose. There is a loose connection. Okay, the second thing we observe is the intake 2 lighting. The intake 2 lighting, when it should turn off when the water level reach above 85%. Okay, when the water reach over 85%, it will trigger float switch 3 to close mechanically, and the current can flow through this path to energize R3 relay coil. Okay, and this will cause this R3 relay switch to close, and the current will flow through the path to energize R6 relay coil and latch the R6 relay switch here. At the same time, trigger the R6 relay switch here to open. So they energize both these parallel circuits. But now what we see is the intake 2 remain open. It means the current still can continue to flow through this parallel circuit. This is so because the R6 relay switch did not trigger to open as it should. So we can measure the voltage at R6.4 to confirm. If there's a 0 volt, it means R6 relay switch is successfully triggered to open, and vice versa. If there is a voltage, that means it remains closed. So most likely the R6 relay switch point 1 to 4 having internally short circuit. Okay, R64. So we measure the voltage, okay, at R64. Okay, there's a voltage here, R64. There's voltage here. That means it did not trigger to open as it should be. So most likely it is internally short circuit. So we need to replace. How about the alarm lighting? It is supposed to light on, so we can check whether it is really open circuit. However, if we measure the voltage here, we only can check the upstream part, but it's okay, we can just proceed and check. Okay, there's a 0 volt. As we know that when you measure the voltage here, let's say the circuit is good, the current will flow through here to the point 1 and branch out into 2 paths. One path to the load, the alarm lighting load, and the other one to the multimeter, and we register voltage. If upstream having an open circuit or loose connection, there is no current will flow to the point 1. Hence, the voltage measure will be 0 volt. as what happened just now. So maybe we can measure the voltage at reset point 1. Reset but push button point 1 is 0 voltage. So we also can measure the float switch 4 point B. Float switch 4, okay, point 8, okay, this is connected to TB312. TB312 here from TB48, okay, it's a float switch 4. So we can measure TB312 here to confirm whether got voltage or not. TB312, yes, there's a voltage, and this TB312 connected to TB210 and TB318. Okay, we can measure TB210. TB210 is here, okay, coming from TB312. TB210 here, there's a voltage, okay, from TB210 to reset push button 1. TB210 is actually connected to reset push button point number 1. Okay, there's no voltage, so possible there is, okay, loose connection or the wire is open within this path, because when we measure, okay, TB312 there's a voltage, okay, then we make TB312 connected to TB210 there is also voltage. However, when we measure the reset push button 1 here, push button 1, where this reset push button point number 1 connected to TB210 do not have any voltage at both of the point 1 and point 10. It means either the wire is open circuit or there is a loose connection or loose termination. Okay, now what we have to do is we just need to press the emergency stop and then count the power supply, perform the lockout takeout, and verify the lockout takeout is done properly. Okay, so we know that R6 relay coil got problem, so we just need to replace it. Okay, and then we need to check whether it's a loose connection from TB210 to reset push button 1. Okay, either loose connection that reset push button point 1 or TB2 point 10, or there's an open circuit in the wiring connection, in the wiring. Okay, let's check here. There's no loose connection. TB210, yeah, there's a loose connection. Loose connection means open circuit. That's why the current cannot flow through the TB210 to reset push button 1. Okay, then we can remove the lockout takeout, and then you see the alarm lighting is turned on. Okay, we can drain the water and try to reset the alarm. After that, we will run the process again to double confirm everything is fine. Hopefully this time do not have any issue again. Okay, the intake 2 lighting is off, is good, and the R6 is able to perform as per normal. That's why the intake 2 can be turned off and the alarm able to turn on. So I don't see any problem here. So the status in the batch indicator should show pass after the process finish. Yes, pass.